All right, so we're going to learn how to take the derivative of e to the x, that's Euler's e, and it's again also for the natural log. You start with the equation y equals e to the x. So we don't have any way to do this right now, but we can use a form of implicit differentiation to be able to solve this. So one of the main tactics to try to get x out of an exponential is to take a log of both sides. Here, if I take the natural log of both sides, I can remove the e, so I will do that. So this is just an algebra step. So ln of both sides. Taking the natural log of each function on each side or whatever. So there's a little more cleanup we can do. So on the right, so nothing to do on the left so far, but on the right, if we use the power rule for logarithms, so that's power rule for ln, still algebra. Now we can write this as ln of y just equals x. This is since ln of e equals 1. And now we can take a derivative. So we know how to take a derivative that has something that involves y, but not exactly y. We know how to take the derivative of a logarithm, which is just 1 over the value times its derivative. So now I'll take a derivative. So this is 1 over the y, which is what we're taking the natural log of, times y prime, which is the derivative of this value. On the right side, there's no ln left. We just have an x. So the derivative of x is just 1. So now we've taken the derivative. All right. As in the previous examples, we have left y prime alone or try to get y prime alone. So here we need to multiply through by y to do so. So we're going to multiply by y. Actually, this is our derivative step. And we know what y is in this case. In this case, we look up top, y equals e to the x, so I can substitute e to the x. So it's just substitution. And we are done. So we know that the derivative of e to the x is just e to the x.